Assalamualaikum to Madam Eliana. So today, my group will present the assignment of the communication principle with the title of amplitude modulation. So this is my group member, Maris Haikal, Amir, Zuhaimi, Nabihan, Bashir and me, Zatiat Uni. So this is the table of contents of our assignment, which is introduction, project methodology, simulation, discussion and conclusion. Okay, for my part is about the introduction. Amplitude modulation, AM, is a modulation technique that has been a cornerstone of telecommunications for over a century. It has played a vital role in transmitting audio, video and data signals over long distance, making it a fundamental concept in radio broadcasting, two-way communication systems and various of other applications. Furthermore, amplitude modulation exhibits robustness against noise and interference, making it suitable for long-distance communication. The wide bandwidth occupied by AM signals also allows for the transmission of multiple signals simultaneously, leading to the establishment of AM radio stations broadcasting on different carrier frequencies. So the history of amplitude modulation dates back to the early days of wireless telegraphy when pioneers such as Guglielmo Marconi and Reginald Fessenden explored the possibilities of transmitting telegraphic signals wirelessly. However, it was Fessenden who made a groundbreaking advancements by modulating the carrier signal's amplitude to transmit voice signals, giving birth to amplitude modulation as we know it today. So for the next part, I will pass to my group member. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabihan bin Zaiful Bahri. I'm from class 2 BEEE, section 11. So now I will present my part, which is project methodology. So amplitude modulation, we will start with the communication. So in this table 1, it shows the communication was carried out by telegraph. And then for the table 2, the amplitude of this wave was varied in sympathy with modulation by a speech message rather than on or off by a telegraph key. And then it goes to table 3. The message was recovered from the envelope of the received signal. Finally, in table 4, the radio wave was called a carry since it was in to carry the speech information with it. And then we go for the next part. So this is the amplitude modulation calculation. So AM equals to E open bracket 1 plus M times with cos micro t close bracket multiplied by cos omega t for the equation 1. And then A open bracket 1 plus M multiplied by cos micro t close bracket times the B cos omega t for the equation 2. So the low frequency terms A multiplied by high frequency terms C for the equation 3. So E stands for AM signal amplitude, M is a constant, and micro and omega are regular frequency in radians per second. Radians. So the equation 4, AT equals to DC plus MT. So that's all from me. Thank you.
My name is Maris Haikal, and today I will show a demonstration for our project, which is amplitude for our assignment, which is amplitude modulation. So this is our simulation circuit, and we use 15 volt peak as a message signal, 15 voltage peak with 11 kilohertz frequency, and as our carrier signal we use 2 voltage peak and 1 kilohertz. Okay. Okay, that. And this is the waveform we get. Okay. That's all for our demonstration. Thank you.
My name is Ahmad Bashir bin Ahmad Tamizi. I'm from class BE section 1-1. Today I'm going to present my part, which is the calculation for modulation index. As everyone can see here, the modulation index is related to amplitude modulation as well as frequency modulation. So the modulation index is directly proportional to the ratio of the amplitude of the information signal and the amplitude of carrier wave So why we need to measure the modulation index? So the reason is because the significance of the modulation index is to measure the level of noise or distortion. So as we can see here, there are two ways to measure modulation index, which the first one is we only need Vm divided VC. So at here we can see 15 divided by 2, which will get 7.5. This is the more easier method than this bottom one, where we can see here this is the other method which we also can use in order to find the modulation index, where first we need to find the A max, which AC plus AM and equal to 2 plus 15, which is we will get 17, and the other one is A minimum, which is AC minus AM, where 2 minus 15 we will get negative 13. So from this result we can make a new equation to find modulation index, which is A max minus A min, A max minus A min on the top one, and for the bottom one where we need to divide it is A max plus A min. By using this equation we will get the modulation index, which means we have two kind of method in order to find the modulation index. And that's all from me, and thank you.
Hello, Assalamualaikum. My name is Amir Faiz bin Mazlan. So for discussion of this project, we know that in AM, carrier wave amplitude constant message signal contain information to transmit is superposed to carrier wave. Second, amplitude carrier wave directly proportional to instantaneous amplitude of message signal. Third, high frequency not carries information but the platform to transmit modulated signal. Circuit that combine carrier wave and message signal to generate modulated signal was modulator. Demodulator is circuit at receiver and separates the message signal. Advantage AM is simplicity, widespread use and compatibility with existing receiver. Limitation is it so acceptability to noise and interference, which can degrade the signal quality. Okay, thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Relmi. Today I will present about in conclusion, amplitude modulation remains a vital component of the telecommunication industry. Its simplicity, compatibility, and robustness have made it reliable and widely adopted modulation technique. With ongoing advancements and integration with digital technologies, AM continues to adapt and find new applications, ensuring its continued relevance in the rapidly evolving world of communication. Okay, one of the key advantage of AM is ability. Ability to easily recover the original signal at the receiver using simple demodulation technique. It is also relatively resistant to noise, making it suitable for long distance communication. AM has been extensively used in broadcasting, allowing the transmission of audio signals over large distance to reach to wide audience. Okay. However, AM has certain limitation. It is less efficient compared to other modulation techniques such as frequency modulation and digital modulation schemes. AM signal occupy a relatively wide bandwidth, making it less spectrally efficient. Additionally, AM is susceptible to various forms of interference and distortion, including noise and multipart propagation. Okay, that's all from me. Okay, thank you.